Hello guys, so today we're going to look into how to deploy a Burn application in production. Burn 1.0 has been out for a few months now and is considered production ready. So we're going to test that notion in this video. So to do that, we're going to try to deploy this Burn app that we built almost a year ago. So it's an Elisha app that uses the Prisma ORM to fetch and display data from a database via API routes. So before we start, there's 3 ways you can deploy Burn apps. So the first way is you can deploy the app as is without changing anything in the configuration. So for this to work, the platform you're deploying to has to support Burn as a runtime. So these platforms include Render and Railway. So we're going to set up this app in both platforms. So the second way you can deploy a Burn app is by building it into a standalone executable that you can run on whatever platform you want to run it on. So this will produce a one-time bundle that has Burn embedded in it. So you're also going to test that in the platforms you're going to deploy on. And the third method that you're going to test is via Docker. So Docker is the best choice for platforms that do not support Burn by default. So as long as the platform supports Docker, it can run Burn. So you're also going to deploy that. And the platform you're going to use to test that is DigitalOcean. So we have a lot to cover in this video. So let's get started. So let's look at our package.json file here. So to start our dev server, we run the dev script here. So we do burn run dev. That will start our server at port 3000. So this is our server. It has a search route where you can search through movies. And it also has a Swagger route where you can look through the APIs that our app provides. So this is what we want to push to production. So let's go back to the file here. So what do we need to be able to push this to production? So the first thing is we don't want to run the app in dev mode. So we need to add another script here. Let's call it start, that will run the app, but just run the src index.ts app without the hot option. So the hot option is for hot reloading. When you change a file, the browser reloads, and you don't want that. So let's save this and use this as a start. So to start the app, we'll be running the burn run start command, which will do the same thing, but hot reloading will be disabled. So let's try to deploy this app. So we're going to start with the 2 platforms that I mentioned that support Burn by default. So let's start with render.com. So let's go to the dashboard. So first of all, let's make sure that we have pushed all our changes to production. So let's commit all these changes. So we have added a start script and then we can push it. Good. So let's go back to render. So we are going to create a new app, which is a web service, and you're going to build and deploy it from a Git repository because you have pushed it to GitHub. So next, so the app you have just pushed is a Burn Prisma Elisha here. So let's connect the app. So let's go through the configurations. So we have pushed in the dev branch here. So let's choose the dev branch and then we can leave this by default and then we can choose the runtime of our web service. So you can see that there's no Burn here. There's just Docker and other stuff that is not Burn. So let's go with Node for now. We're not going to use Node, but we are going to configure everything to use Burn instead of Node. So the build command you can see here, it's burn install. So render has detected that we are using Burn. The start command here is burn run start. We have just added this start command and then we can use the free instance type for now because it's for testing. And then we go to environment variables. So if you look at our app here, we are using the Prisma ORM here, and the Prisma ORM expects you to have the database URL properties when you're deploying your app. So you can use whatever property you get from your hosting provider. So for example, I use a Supabase for my databases. So all I need to go is go to my Supabase dashboard and go to the database that I use for my app in production and then click connect, and then you'll get this database string that you can use for your database URL property. And then also another environment variable that you can add to your config here is the Burn version variable. So you can specify the exact version of Burn you want to be used there. So for example, you can say I want to use the Burn 1.1 version, and render will use this for the installation tasks. And another point about the database URL that may trip people up is if your database hosting provider provides you with the database URL like this, right? And then inside the password, you get an auto-generated password that has all sorts of characters. So it may be something like AS with a $sign and an @ and a backslash and some other weird characters. So these values will pollute your database URL, and Prisma will not be able to connect to your database URL. So what you need to do is you have to encode these values. So what I do is I just open a node console and I use the encode URI component function here to encode the database string into a format that can be read by Prisma. So if you encode the password they give you, you get a value like this, and then you can now pick this value and then substitute your password with that, so that the database string is not corrupted with the characters that may conflict with other characters in the URL. So back to the setup here. So with these two variables, we can continue and create the web service. So there is a bunch of advanced options here that you can add. For example, you can add a .env file that the secrets should be read automatically, and these values will be pre-filled, and some other stuff that you may want to configure. So with that, we click the create web service button and we wait for it to build. So you can see it's still preloading Node.js, but it has also detected that it's using Burn because you've added the Burn version using Burn 1.1, and then it's now running our Burn install tasks, Burn install, and then deploying the app. So it's now running the Burn run start command to start the server. So our app has successfully started and is live. So let's try to preview the app. So let's try to click the preview URL here, and you can see the app is now running. So we can try to go to the search route where you can see the results. So that means we can search for movies and it will work, and we can get a movie title, for example, and it will work. So our API works. So let's try the same process by deploying our app on Railway. So let's start a new project. We are going to deploy from GitHub, and then you're still going to deploy our Burn Prisma app. So before you deploy, we need to add some variables, and that is the database URL property. So the same variable that we are adding to our render app here. So let's add it. And then before we start, there's some things we need to change in our settings tab here. So let's first start with networking. So we need to make sure that our app has a domain that we can use to preview once it's completed. And then another thing, make sure that you are building from the correct branch on GitHub. So we want to build from the dev branch. And I think that should be enough to start for now. So let's click deploy and cross our fingers. Let's hope that it will work. So we can follow the deployments under the deployments tab here. So our first deployment failed because we hadn't set up the configuration properly, the variables. So let's go to the building app here and then watch for the logs. So it looks like our deployment failed. We are seeing errors here, cannot find module .prisma client index when running the start script. So this is a familiar error. It means that the Prisma client was not created. So if we go back to our app here, when you're running the project in a development environment, we always run the Prisma migrate dev command. So this generates the migrations and also generates a Prisma client that Prisma can use to query the database. So in a dev environment, we just run run migrate dev. So this runs this script here, and then you can see Prisma loads the schema, looks if the schema is in sync, and then generates a Prisma client. So you want something like this in production, but you can't use the migrate dev command. So in production, it's a similar command to this, but instead of running Prisma migrate dev, we run Prisma migrate deploy. So instead of dev here, we can call it maybe prod. And then let's commit this. So we can call it something like migrate deploy, and then push this. So what we need is to run this script when the app is building. So we go to the settings, and then under the deploy settings, we can modify the start command. So the start command is a burn run start. So what we can do, we can run our migrate prod script before we run burn run start. So this generates the Prisma client before starting the app. So let's test and see if this will have some sort of effect. So again, we can follow this under the deployments tab. I think you can follow the latest deployment here that we've just changed right now. So looks like the build completed successfully, but you're still getting errors. It still looks like we still cannot get the Prisma client to generate successfully. So that command did not work. So as a last resort, let's just test something to confirm if this works or not. So let's go with another method. So in the deploy function here, let's try generating the client manually. So what I mean is this. So inside our app, we do Prisma migrate deploy, which runs the migration together with the generating the client. But you can just generate the client without going through the migrations, because it looks like with our errors in our deployments here, the database connection is not working. I don't know why. And remember that we are using the same configuration we used for our render app. So if we go to our render app here and look at the deploys, all of them are deploying successfully. Every change you're making is deploying successfully, but it's not working on a railway here for some reason. So let's go. So what we can do is, instead of running the migrate deploy command, we can run something like Prisma generate command, which just generates the Prisma client and doesn't generate the migrations. So let's try to patch this on the fly here, just as a test. So for our app here, let's go to settings and then try to tweak the deploy command here. So we want to do a Prisma generate command, which should generate the client before starting the app. Maybe this will work. So let's try it. So let's follow it. Should be under deployments, the latest deployment here. So it looks like the build is done. Let's wait for the deployment. Another error here. So looks like the client has been generated successfully, but now you're now getting something that is completely cryptic. You're getting shared library error files here. So we could look into this further. I think I've lost my patience. We need to try something else. So it looks like there's something within the railway build toolkit that doesn't agree with our Prisma client here and ban, because we can confirm that the build is happening on render. So what we can do, we can try the second method of deploying this app by going the Docker way. So let's try to Dockerize this app and see if it will build this time. So ban Docker deploy. So you can go with the first result here. So this is the config that ban recommends when running your app with Docker. So you're using the ban image in Docker and then configuring our app here and then finally running it. So I think we can start with this as our base and remove maybe any noise that we don't need. So let's just copy this and then create a Docker file that we're going to work with. You know what? I'm just going to get rid of all this in between here. So first of all, we don't need an entry point because we have a package JSON here. So you can just run our start command here with ban and then let's install the dependencies. So that means copying our package.json and the ban log file to the root here, and then running ban install, and then copying everything else to our working directory. So one thing we need to be passed as an argument is the database URL that we provide as an environment variable. So it will be directly passed to our Dockerfile. So with the database URL, we want to generate the Prisma client. So let's copy everything in Prisma to our working directory here. And then what was the script we added? The migrate dev script. So let's run this with the Prisma CLI. So let's run, so ban run migrate prod. So this should generate the client and run the migrations. Are we missing anything else? So I think we've covered everything. What we can add is maybe expose the node.env variable so that we know we are in production. So let's commit our changes. So let's add everything and then let's call this Dockerfile. So let's push this and close our fingers. Let's hope it will work this time. So let's wait for the deployment to complete. So it looks like it's working. So our app has started successfully. So the Dockerfile works. So let's try visiting it. Looks like it's not working again. So there's one final piece to the puzzle that we need to configure here. You see here our app is starting on port 3000, right? So unlike with render, which automatically checked if any open port was open and then exposed it to the internet, for Railway, you have to manually expose. So one thing we need to do is go to the project settings and then under variables, we add a new variable. Let's call it the port, and then we add a port that will expose it to the default port for the internet, so that when you click on the app URL, the app will be properly exposed to the internet. So what we need to do is add this, and then while this is deploying, we also need to make sure that inside our app we use the variable from the environment. So here we're just using 3000 by default. So what we need to do is declare a new variable here. Let's call it port, and then now we can read it from process.env from the env variable, or use the default 3000 port. So let's push this. So let's call it env port. I don't know why I misspelled that. So let's call it env port, and then we can push it. So let's wait for it to build. So let's check on the deployment. So looks like the app is now properly exposed to the correct port. So that means we'll be able to access it on the Railway URL here. So if we click on it, hopefully, yes, it now works. So we are now able to access our app on Railway. So this was really a pain to set up. It was not as easy as Render. So I can say Render is the easiest of the two that you have tried so far. And the big disadvantage with Railway is everything doesn't work by default. So we had to jump through hoops, and finally we had to go back to using Docker to get it to run, which is a good thing anyway, because we are going to figure out how to deploy with Docker anyway. So since we now have this working Dockerfile, I think we can deploy our app virtually anywhere we want. So let's try to deploy it to DigitalOcean. So let's open DigitalOcean and try to deploy this. So with the DigitalOcean, it doesn't support burn by default. So the only way we can deploy is by using the Docker method. And the fastest way to deploy using Docker is to use the app platform. So we're going to create a new app using the app platform, and we're still going to load our project from GitHub, the same project. So let's choose the repo. So it was Ban Prisma Elisha, and then we're still going to go with the dev branch where we are working on. Yeah, let's sort of deploy and then click next. So if you look at the resources here, DigitalOcean tries to determine the apps that you are. So because it looks like a Node.js app, we have a package.json and you have JavaScript files inside. It detects a web service, and then because we have a Docker file, it detects a Docker service. So we don't want to use the web service. So let's delete this. We want to go with the Docker service. So let's edit it. So resource size, we can go with the smallest droplet just for the test. And then, yes, it's going to yes, it's going to use the 8080 port to expose the app. I think that should be all. So let's save this and then go back and then go next. So again, we need the database URL environment variable. So we need to set up database URL. So again, I'm just going to copy whatever we are using for Railway here. I think it's under variables. So let's copy this and then paste it there and then save. So let's go next. Region, yeah, we can go with that. There's no problem. And then we go next. I think that should be all. And then we create resource. So ideally, this should launch with no problems. So let's just wait and see. You can watch the build logs. So looks like it's deploying. So the build was successful and it is done. So if we go to the app URL, then you can see it has deployed successfully. So our API also works on DigitalOcean without having to update the Docker file. So just to finish up, there is something else I need to cover, and that is building an executable version of your burn app. So this is a burn application that does not do a lot. It just returns a hello message and uses the HONO web framework. So we're going to use this to try building the app into one executable. So to build a burn app, let's add a build script here. So we use the burn build command. So that burn build command takes a file and an entry file, which is our index.ts file here, and then we can pass arguments like, for example, minifying the file, and we can provide an output directory where the minified build files will be saved. So if we run run build command, our file here will be built to JavaScript, and then we can see the output in the build folder here. So this is the minified version of the file that we can just run via the run build index.js file. So this is just our TypeScript file compiled and then minified. What I wanted to highlight was the option to have all these output into one file. So instead of transpiling the file to a minified version of JavaScript, we could compile it into one executable where we can provide the out file argument and say save it in build app, for example. So if we run build again, the same app will be compiled, but this time instead of it being in a JavaScript file, it will be in an executable file here. And you can see it's quite a large file. It's 90 MB. So this file is embedded with burn and your app itself. So it can run standalone. You don't need burn to run this file. So to run it, you can just run it as standalone like that. So you just run it without ban or node or any arguments. So we are not sure if it's running here. What we can do just to confirm that it's working, we can log a message here. So let's rebuild the file and then try to run it again. So you can see that the app is running and we can access it on port 3000 like that. So the advantage of building your app like this is that it will be faster to launch because there will be no transpiling going on from ban, and there's no extra overhead of having to launch ban with running the commands and everything. So it's a bit faster than running with the ban run, for example. So what we can do, we can have this dev script that runs the ban run command, and you can also have a start script that simply runs the build app command. So when you deploy this, you have to build the app first so that you can then run it. So you can test this. So let's push this. Let's call it ban build and then push. Yikes. And then push. And then what do we use? Yeah, we can try using render to deploy this app. So we create a new app. It's a web service. We are getting it from Git. We want to deploy the Honoban app, and then you want to deploy the dev branch, and then the build command. We want to ban install and also ban run build so that it can run our build script and generate the executable. And then finally we run ban run start, which will launch the executable. So let's still go with the free tire. Do you have environment variables? No. So let's create the service. So you wait for the app to build. So you can see after installing, it runs our build command, which builds the app into this app executable and then runs it. So you can see the server is up and running. So that means when we try to visit the website, it works. I love render so much because I don't need to configure anything. It just works. So that is almost the same experience we had with deploying the ban apps. But the problem is this doesn't always work. So for example, if we try to go to our ban Prisma app here, so let's try to build this app into one executable, right? So we can add a build script which runs the ban build script. So let's try to run this. So ban run build like that. So it will build the app into an executable inside our build folder here. So this is the file, 91 megabytes. So let's try to run it. So it's in a build directory, the app file. So you can see immediately it doesn't work. So the server starts but exits immediately because of something else. There's always something. So if you try to compile it into an executable and it doesn't run, I think you can just leave it there. It probably means there's some API that ban has not fixed yet. So the process is always you highlight the text, you copy it, you go to the browser, you try to Google it, scroll through the links looking for GitHub issues, find one, click on it. Looks closed. So maybe it was solved. Scroll through the comments, nothing helpful, nothing helpful, nothing helpful, nothing helpful. Locked as resolved. So who locked it? Please see the issue in the previous comments. You're running into that one, not this issue. So they're running into something else, not related, but looks related. Cannot find variable, require. Click on the issue. Still open. Go through the comments, nothing helpful, nothing helpful. Oh, from Jared. Oh, this will be tricky. Require that cache will be empty, but it doesn't work because require is not defined. And require is not defined because the transpiler is not run again on bundled file. So the question is, why doesn't require.cache get rewritten to import.require.cache, which should at least get past this error? So Jared is thinking of something. He already knows the error. Here's the error. The bug is that we aren't injecting require into the file. Instead, we're using import.meta.require. We need to inject require at the top of the file. So he knows how to fix this. Has he fixed it yet? No. Any updates on this? When was this posted? Last month. This is where you lose all hope. You have to wait at least a few more months for you to be able to do this. So it's not worth it. So it comes down to these two things. If you want to deploy a ban app, use a platform that has ban support already. So that is Render, which hasn't given me any problems during this session, or you can go with the Railway, which has been a pain to work with, but it still works. Or if both of these don't work, then go the way of using a Dockerfile. So you can deploy to a platform like DigitalOcean, or you just go with your Dockerfile and then you're able to deploy your app. So that should be all. I hope you learned something new in this session. So thank you so much and see you in the next video.